All right, good morning. At least still morning here where I'm at. And today we are going to wrap up. I'm going to call this 3 of 3. I've been doing 1 of N, 2 of N. We're going to say 3. 3 streams to get the dev environment all set up and working the way I want so I can do more rapid iteration on researching ESP32 type things. Excuse me. And so that's what I'm going to be working on today. So far we've got this set up. So where we left off last time, let's start there, is creating this prompt to show what the current IDF target is. I wasn't sure if I liked the way that the rest of the prompt looked with the username and just the end of the path. So this doesn't show the full path. But I think I'm not gonna dwell on it. That's where we're gonna leave it. We're gonna stop there. And the only reason I don't even need to know that I'm the Ubuntu user. I know that. And the only reason I'm leaving it is because if I pull up another VS Code instance that is not in a container, so it's on my local machine, this prompt is just you're ripping raw on your local machine. And so this is just an extra visual indicator to me that I am in fact in a container, and so that anything I do is safe and not going to cause any issues on my local machine. And so I like, if that's not there, it's feasible that I could be on a terminal that's actually on my local machine. So anyway, it's a short. I could change it to some other shorthand to let me know I'm in a container. But for now, I'm just going to leave it. And if I get working on it and I decide I want to change it later, I will. That's the beauty about all of this. And so just as a quick rehash of how we got that set up, we have this little bash aliases, which is included every time a terminal is opened. And this is just some bash magic that the robot helped, that has some shorthands for doing different things. And so these are like color codes. That's why we get some of this green and blue. And anyway, you can use whatever your favorite AI assistant is to help you modify this to make the prompt look however you want. But for my purposes, I'm going to leave it like that. And so we're all good there. I think the next thing I want to do is setting the target. And I don't want to get overly complicated on this, because right now what I can do is I can say export IDF underscore target. This is what the build system will pick up. I can say export IDF underscore target equals ESP32 S3. And then you'll see the target here changes. And so when I'm in, and I showed this in the last stream, when I'm in one of these example projects that I'm messing around with, it'll now clean build for that target, just by setting that environment variable. But I could also do something like this, IDF target equals Kevin. And it's gonna be like, great, your IDF target is Kevin, which is not a valid IDF target. And so, Ibrahim, welcome in. So I would like to, again, not get too crazy, but this should not be allowed. And I'd like to be able to easily switch between valid targets. And so I think having some way to do that that's also built into the bash system that allows me to set the target to something valid or even choose it from a list would be helpful. And so this is another example of where the robot is super handy. I'm not a bash expert, and so let's just bring the robot into the conversation. And I know I'm right here, like right behind my body is where I'm typing in the prompts, and I'm too lazy to go into OBS and move myself. And so you'll see the output up here though. So I'll tell you what I'm typing as we're going. As part of my bash, let's see. I want to enhance my bash aliases. How do I want to word this? To select an ESP32 target, which will then set the end variable IDF target with a valid value. What do I want to call this? Set target, yeah. From the command line and have it present me with numbered options. I select a valid number, it will set the M variable to a valid ESP32 target. Let's just look up, because the robot can probably figure it out, but let's look up. All valid ESP32 IDF target values. I don't even know what they all are. It'd be nice if we had a single spot where they all were. Oh, list targets. Really? IDF.py list targets? Let's try that. Look at that. All right. Beautiful. Learn something new every day. Let's just copy that. And tell the robot, here are all of the... Is P4 in it? P4 is in there. Here are all of the valid targets. Oh, I meant to change it to Claude Sonnet. I can do Claude Sonnet 4 now. You cannot see that. Nope, my chair's in the way. You still can't see it. Echo available targets. Okay, perfect. I've added a set target function to your bash aliases. And like, sorry, again, just my personal philosophy on a lot of this stuff is use the built-in Linux tools. Like, you could write a Python script to do this. You could write a Node.js. Like, you're bringing in a giant framework when everything you need is right there in bash. Like, you can do a lot with the built-in Linux tools in a bash script. And again, I'm not a bash script writing expert, but the robot is pretty good at it, and we can check its work. Okay, and it says it is done. And so let's see, it has all the things there. Select target. Oh, and it has a choice. Error, invalid select. Let's just test it. We're going to hit keep. We're going to source it. Okay, we didn't get any errors, which is good. So that's a good start. And now I just want to do, is it set underscore target? I really want it to be set dash target. I'm trying to get away from underscores. It is set underscore target. Let's just change that. Okay, set target. Not found. What does it alias it as? That's probably echo update prompt read. What am I missing? Source by simply type set underscore target. But where does it do that? Just change it. Maybe you can't do a dash there because this is the function itself. Okay. Guess we can't do it that way. Oh, it doesn't like that. I tried to run set underscore target and got a command not found error. I think they need to alias it. No, that's, I don't want to do that. Oh, I know why. I know why. Yep, that is correct. Okay, so we can do set target. This is in, sorry, I am in the dev container. I'm editing the bash aliases that will get built into the image, which does nothing because the container's already built with the image. And so that's just not going to work. I need to be editing the local one, so it is correct. So let's allow that, which it will do. And not, yeah, that's, well, whatever. We can test it from here. Set target. Okay, and there are 10 possible targets. Let's do target 0. Okay, so it just kicks me out if I make a mistake. Let's select the C6. That worked. Okay, I mean, it could be sexier, but that's probably good enough. Okay. Yeah, do I want to go any fancier than that? Maybe not. So let's leave that as set target. Target. Set chip. Let me see what's more natural to type. The dash is even. Yeah, maybe I don't want to dash at all. Let's do set chip. Set chip. Great. Great. It works, but in the event of an invalid choice, I would like it to prompt again. Also, the list is pretty long. Split it into 2 columns. Make it look pretty. All right, the robot seems to be stuck, so we're gonna do that. Okay. And let's see. And a 2-column layout. Siddharth, hey, been a while. I believe you've been in the stream a few times. All right, we're just gonna, oh, it did make it look a lot prettier. Okay, let's keep that. I am building out my dev environment again. So this is the 3rd stream where I'm doing that. I'm just kind of finishing up, adding some sugar to it, where I can do rapid testing of various things in ESP32. So this is all in VS Code with Docker, nothing on my local machine other than Docker and VS Code. And I'm just working through some things to make the experience, the dev experience, a little cleaner, nicer. So yeah, that's what I'm working on. All right, so let's try this again. Let's do source dash aliases. No, source. Nope. Dot. What is it? Workspaces that dev container dash aliases. Gotta be a dot. Dash aliases. Okay. All right, so let's do a clear here. And let's do set chip. That is going to drive me crazy. There we go. Get this little indent there. All right, ESP32 target selection. All right, I want to pick the S3. Well, sorry, let's see if they fixed my thing. So I'm going to say 0. Invalid selection. Please choose a number between 1 and 10 or Q to quit. 11. Great. And let's select 4 for the S3. IDF target set to ESP32 S3. And you can see it's right there now. Nothing prevents me from setting the IDF target directly, but why would you ever do that? So set chip. Let's go back to the ESP32. Great. Okay, I think we'll call that good enough. Like, we're not trying to get super crazy here. And I would love a new line here. Let's try that one more time. Set chip. Oh, you can't just do new lines in Bash? Add a new line. You know what? I do know a little Bash. We can just do this. Echo like that. That should work. Set chip. Let's go to the C5 9. Yeah, there we go. And you can see it updates here. So cool. I think just a little bit of that to help me set the target should be good. Let's clear that out. Great. So now the test is we're going to rebuild the container. And close the robot. And I don't have the chip plugged in, so let's retry that. Okay. I just did build the... I just did. Okay, and you can see it defaults to ESP32. I have IDF.py. Siddhartha, great question. What are the benefits of dev environment versus ESP IDF project? So this is raw ESP IDF. The difference is it's all built into a Docker container, into a Docker image, which then makes a Docker container. And that's all controlled up here by the Docker file here. I pull from the official Espressif image, so it installs all of the tooling and everything I need for this exact version of the IDF. And so if I want to change that version for a particular project, all I need to do is change this, rebuild the image, and I'm done. I don't have to worry about managing that on my local machine. It's all handled within Docker, which is amazing. And then I can install any extra tools or whatever I want in this environment. And then I'm changing the prompt so that it looks nice and fancy and tells me what my target is, and I might not want this running on my local machine. And yeah, that's about it. And then I have the tooling out of the box. So I do not use the IDF extension where you can have little buttons to click and stuff. I just like to do everything from the command line because honestly, for me, it's faster that way. I can do IDF py build, flash monitor, all those things. And I just use menu config directly. I don't like the built-in VS Code extension for that. So anyway, personal preference. So yeah, great. We are now all set there. You can close all this. Oh, okay. And then let's just try our set chip now. Sweet. Let's do the ESP32 S3. And it is set there. Cool. All right, that is all we're going to do for the environment for now. That looks like it's in a good place, just enough. As I go through this, I might enhance this a little bit more, but as a baseline, this just allows me to mess with different chipsets in different projects, which I'm keeping in these examples, examples is fine. And yeah, this main is empty, so we can get rid of it. let's do that. Let's clean up the whole thing so I can commit it all to source code, which I have not done yet either. I kept this partitions because this is like my standard for doing OTA, but I can always copy this back in whenever I have an example that needs that. So I'm going to delete that permanently. The README doesn't have much in it. The changelog doesn't have much in it. We're going to call it today, which is 11/12. 11/12. Initial release. Like to know what I change. Great. Now, these all look good. These are set up the way I want them set up. Yeah, great. Cool. So now what we're going to do is yes, so I'm at the root at this point. Great. And so let's do a git init. Empty git repository. Perfect. And you can see I have 797. So the very first thing I need to add is a git ignore. And let's take this and I'm just going to grab another project that I use and get a template. We don't have to reinvent the wheel every time we do this. So git ignore. Okay, so let's see. We want to ignore dependencies.lock. I think that'll do it everywhere, but I'm not sure. Managed components, build folders, and let's start with that. Yeah, let's start with that. Okay, so now we're down to 19 files. So that looks good. And let's see what they all are. It should just be... Okay, minimal build, my SDK config is in there, which I don't want it to be, but I do... Well, for the purpose of this... Ahoy, Gindrax. Welcome. I don't know that I ever want to check in an SDK config into this repo. Let me think about that. Because I really just want the source code, and I wanted to generate all of those anyway. Let's see. CMake list. This all of this looks good. Kconfig, great. Bash alias, yes. And if I come look in one of these, for example, yeah. You know what? I want them all to be the same anyway. So if I want to keep an SDK config, I'll do it the other way. So let's do this. Great. Yeah, that'll work. And then actually just reproducing minimal build every time should be all we need to do. Where was the SDK? Oh, here. All right, so let's delete that. And then let's go into examples, minimal build, AF.py build. Ah, yeah, because I built it in the other thing. So let's do AF.py full clean. It tells me exactly what it needs. Great. Done. And now I no longer have an SDK config because it would have dumped it right into here, which is excluded from my build folder, which is by default what I want. And if I don't want that, I can always change it later. Okay, so, and yeah, it's excluding this dependencies.lock, which is also fine because I do have the component YAML here. Just for kicks, let's look at an example of theirs. IDF component, they're not checking in the dependencies lock, so we're not going to either. Okay, great. 18 files, and I believe that's everything we should want. Let me just take one more look at everything here. Main, that's the minimal build. It's showing me the things that it's excluding. Minimal build. So I've got two things, including components, minimal builds, and shared components is where the Wi-Fi stuff is. Great. Forget, ignore, change the log, and readme. That seems to be the minimal set of things I would want. Let's stage it all. And do initial, wow. Initial commit. Okay, great. I have nowhere to publish it. I will go through and set the branch and stuff later and push it up to GitHub. For now, we're going to call that setup, just the way I want it. And now I got some time left. Let me come over here into my things I want to stream about and see. Oh, woof. Okay. I do want to, this is part of the development setup. Okay. Kimu, I think is how you pronounce it. Let's start messing around with that. ESP32. So this is a way for you to run firmware without actually having a physical device, which I would like to do. Well, I always have physical devices, but I don't know. This could be interesting for some testing. I don't know. I want to play with it, and Kimu requires a bunch of things that we're going to need. So in the development environment, like all this stuff, right? Like we need to have these things in there. So to use Kimu with ESP. So what I'm going to do is here's you can just look up the guide, Kimu emulator. I'm going to pull this out, put it up on my other screen over here. I'll get it out of your way there. And we're going to follow. Basically, I'm just going to go through the instructions here and see if I can get this all figured out and set up or not. So let's see. Usage. To run an IDF application in Kimu, use the following command. So install the pre-built binaries. Okay, so for Debian, yeah, I don't think this is gonna work. I'm gonna switch over to the README. Internet controller, Wi-Fi, Bluetooth. You can't do any of those Wi-Fi or Bluetooth things. Okay. The idea here is, and I'll just show you this, idf.py, you can do Kimu monitor. And I have no idea. This is, wait a minute. I think that totally just worked. This is my dev kit. You can see there is no red light on it. I have no power connected to it. I have no devices connected right now. And this is the firmware in the minimal build. So did we just get it for free with the IDF? It totally looks like it. Running QEMU on socket. All to list of commands. It just totally did it. Generating flash image, QEMU flash.bin. So I'm assuming if we come into the build folder here, we're going to see that. QEMU flash, QEMU efuse. Wow. Okay. Totally for free. I was expecting to have to install some stuff and do a bunch of other things, and it is just working. I have nothing, again, no devices plugged in. This is totally running in simulation in QEMU. And let's show that. Let's just do close all. Let's come down in here into our main for our minimal build. Oh, actually, let's do the chip set. New. What is the ESP IDF call to get the chip type? It's going to be some system call I don't know off the top of my head. Let's see if he can get it. Well, yeah, it's not. Okay, it's looking in the... Yeah, sure, go ahead. Look around. Poke around. This is definitely the long way to go. I need to just go to the documentation and look it up. I'll let the robot churn on it for a second. There is just a system call. Grep chip void. Yeah, sure. Go ahead. Okay, no, you're done. No, robot. Skip. Stop. I'm being lazy. Let's see. API reference is what we need. API reference, system API, app image, chip revision, version scheme. I don't want the version here. I want like this is an ESP32 S3. Get Mac. Get chip version. If anybody on the chat knows, call it out. Otherwise, we're going to sit here and wait for me to find it. Over the air, logging library, interprocess, communication, heap memory. It's really the target that we're getting. Get target info. Looks like it's gonna be ESP loader, ESP, no, what is this? Nightcry, work, yeah. You haven't missed much. I finished up setting up the dev environment, and now I'm fumbling around trying to find out how I can look up the chip target information in IDF. Because I'm playing around with QEMU. And the robot wasn't helpful at all. Snap trace, good. Really, I would have thought this would have been really easy. Yeah. Basically, well, actually, you know what? We're wasting our time. Why are we doing this? We're wasting our time. This is so stupid. The ROM bootloader spits it out to begin with. Fairly certain. Multi-core app. Flash chip download. Maybe not. Maybe I'm making that up. Here's the chip rev. Yep. Min max. Sure. And that's the very... Yeah. It's not. All I want to do is to show that my set target is working. And that it's actually building for that target and running in QEMU. That would be like a great way to round out the stream. SOC capabilities. Let's see if there's a target on this. Nope. That is interesting. Interprocess calls. Internal and unstable APIs. Maybe that's what we want. Nope. Standby. All right. Chipinfo.model. Yeah, okay, so that is all we need to do. All right, let's mess with this. The robot helped me that time. ESP found to include ESP chipinfo.h. Oh, we do need to do some more environment setup. This is extremely important. Okay. So let's just, I don't know if the robot just made that up, but I know ESP system works. So if I hit GD in Vim, go to definition, I get nothing for that. And the reason for that, so this is very important, is we need to add a VS Code a VS Code folder. And in that, we need to add a bunch of stuff. So I'm just going to grab this from another project that I use. And right at the top here, we're going to do new folder. Now, a lot of people say don't check in the .vs code folder because that's your local setting. Like, it does contain local settings, but as you'll see here in a second, I'm going to do new file, c_cpp properties.json, and we're going to edit this. I don't need the ADF. I don't need this. What I do want, though, is not home Nomo ESP IDF. It is, what is it? C-opt ESP. Okay, so /opt ESP opt. ESP, just like that. Okay, so with that, it should find everything we need so that when we come back up here, you see the squigglies went away here. And now I should be able to go to definition. And now this is super important as part of the development setup. Now I can go through and we can go as deep as we want on this. So now I'm in system.h. Let's do a, well, here, let's, first of all, we've confirmed that chip info is indeed a header. And we're going to call this ESP chip info. So let's do that. And then let's show how this is powerful. We're going to say ESP. You get IntelliSense. So right there, auto completion. Yep, that's what we want to do. And that's what we want to do. Like once you've told the tooling here in ESP and in VS Code, like where things are, it can really, really help you. Okay, so great. And now we're going to just do what? We're going to, the robot spit this out. So let's do this. Yeah. Let's just take the robot's code and oops. Dump it in here. Okay, so anyway, from that chip info, you're going to get a model, which is just going to be an int. But we can look at this, right? So what does ESP chip? First of all, what's the struct look like? We can see, oh, the struct has a model, features, revision. These are just uint 32, 16, 8. The model is a model type. We can go to definition of that, which took us nowhere. That's weird. No, there we go. Okay, so it'll show you, oh, look at it here. It'll tell you what all the numbers are for all of those things. And so really, really handy. And then we can even go down into like, what is chip info doing? VS Code will say, well, there's a lot of chip info C's here. Do you want to look at the ESP32 C2 one? Do you want to look at the C3 one? It's different for all of them, but let's just go into the C2 one, for example. And you can see, it's just, the way this works is it's literally just setting it to a define for the model. The revision calls this efuse how chip revision. What does that do? We can go to definition. This calls efuse how get major chip version. What does that do? Like you can go as far down the IDF, and this is super helpful. A lot of people don't like to dig inside of the box. I highly, highly encourage you when you're messing around with your projects. All things you're not going to get in the Arduino editor, where you can really dig down in and just for your own knowledge understand, hey, this is what it's doing. You'll eventually get to the very bottom where you're like at the technical reference manual level, where it's saying this is the actual register that gets set or read to do this particular operation. So you can really just, it's all open source for the most part. There are several parts of this in IDF that are pre-compiled binaries they do not give you the source code for. By and large, most of it is open source. Okay, cool. I should have started a new example project here because we're messing with Kimu. Oh yeah, Nightcry, that one's biting you. Yep. So anyway, super, super handy. Let's come all the way back up. And now again, we got really sidetracked from the fact that we are now doing this inside of Kimu. We should be in our minimal build here. Be able to do idf.py/monitor. For anybody that has joined, again, I have a dev kit here, but you can see there's no LED turned on that. It is not plugged into my USB hub. I have no hardware whatsoever, no ESP32 hardware connected to my computer at this time. But I'm going to build in monitor. And it says it can't open the serial port. So what happened? We were doing so good. Oh, yes. Because I have to do idf.py Kimu monitor. And let's see, I assume, yeah, it looks like it does a rebuild. So check it out. Chip model, ESP32 S3, and it's doing my code. Let's go ahead and change the code just so you know that I'm not. Hello, we are in Kimu. Hello, we are in Kimu. Check it out. Okay, now our chip model, it's running, simulating an ESP32 S3. Again, I have no hardware whatsoever. Really cool. Now, there are limitations. I was just looking at a little bit of the... I might still have it up. Let me see. Nope, not there. Let's see if I can find where we were. Anyway, in Kimu, you're giving up... you're not going to get Wi-Fi. You're not going to get... let's just look at it here. It had the Kimu remake. Let me just bring this back over real quick. Okay. Check it out. It's going to say choose your target. Yeah, whatever. Supported features, you can see it's got a lot of green check marks, but once you get down in here, like Wi-Fi, Bluetooth, USB, like you're not simulating those things. It does note here, Wi-Fi, the Ethernet controller can be used for networking instead. So I'm not sure how that works. It says this is not for Ethernet. This is not a real hardware peripheral. It is used to have networking. It is used to have networking and emulated targets. So anyway, but for just regular old, I can't afford any hardware dev kits and I just want to mess around with the ESP IDF, this is your way to go. Like out of the box, totally supported. But now let's try and do our cool set chip. And let's change it to a P4, ESP32 P4. And then do an IDF.py full clean. And then do a Kimu monitor and see what happens. It should build this for the P4. And then it should tell us that it's running a P4. Oh, check it out. Kimu is not supported for the P4. Okay. Fine. I didn't want to use P4 anyway. Let's pick a different one. What was my last one? S3. Let's do the C2. Let's see if I can pick every single chip that's not supported. But anyway, hopefully you can see like the power of having the environment set up like this. I literally am. Okay, let's come back to the stinking... Okay. It is supported on the ESP32, the S3, and the C3. Those appear to be the only 3 targets that are supported. So let's pick one of those. Full clean set chip. What'd I say? The C3. So this target should be supported. And just if you're new to ESP32, like the ESP32 S3, why didn't it? Interesting. It did not print out our architect, like what chip we're using. And it also, yeah, why didn't it? It didn't even print out unknown. That's weird. Okay, so I guess what I'm learning here is your mileage may vary. We are running in the S3 now. Let's. It didn't even print this, the chip model. Did it? Did it just do it somewhere up here that we didn't see? Let's do a, maybe we're just catching it to, let's do a standard, this thread, sleep for 1 second. Maybe there's just a timing on startup. Maybe, check that. Maybe it just wasn't connecting fast enough. All right, but anyway, okay, so you can see we're using the C3 now. And I was in the middle of saying like the ESP32 S3 is like the new flagship, like standard. Obviously, you know, look at specs and requirements, but it used to be like the ESP32 just raw room modules, but the replacement for that should be used for all new projects as a drop-in replacement is the ESP32 S3. So it's one of the flagship chips is what I'm saying is supported in Kimu. So the P4, some of those things that are newer and have different capabilities, obviously are not supported yet. I don't know if there's plans to support them. Oh, Nightcry says they are marking up the ESP32s pretty a bit. Yeah, I mean, everything's getting more expensive. And so this is a great way on a budget to just start playing around and learning. You can write all sorts of programs. Obviously, your interaction with hardware is extremely limited, but yeah, cool. And then I got another question here. Are you using C++ here? I am. This is all C++. The IDF is written entirely in C, so as soon as you start making calls like this, you're going to end up in a C file somewhere. It supports both, but this is actually C++ 20. So all the features of C++ 20 should work. Syntax and semantics and things like that. Okay, so now I'm curious, because it says, okay, timers, HMAX, RSA, AES, UART. It says that the UART works, but I don't know how you would, like, I'm not sure what you would do. Like, how do you test the UART in QEMU? I don't know. Oh, and so interesting. Here's another thing. This is also dev environment related. Let's just keep going. All right, so we got QEMU working. We got it for free because we're using the base image. Let's go one step further and see if we can get step debugging working to where in QEMU, like if you've got a function that you're trying to figure out why is it crashing, we could actually step debug this. And I'm looking through here. Interesting. Run QEMU. I'm just reading through docs here on the side. ESP32 QEMU. Let's look at the emulator. To debug, use the following command. Let's try it. idf.py. And it just says run GDB. This command builds the application, starts the QEMU with the GDB server enabled, and opens an interactive GDB session. You can use GDB to debug the application as if it was running on real hardware. Okay, so that takes us here. Okay. So, yes, we are now... Okay. That's super handy and nice. Yes, we have a GDB session going. We're attached to it. If you are a GDB pro, more power to you. What I would really love is if we could get this to work, where I've got a little run and debug in VS Code. That would be super cool. I'm going to hit Q here to quit. Will be detached. Yes. And we're done. Okay. It is also possible without the IDF monitor. Yep. Graphics support. Great, 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 great. eFuse. Okay. In VS Code with QEMU. Sorry, I could pull this over here. All I'm doing is internet searching at the moment. You can any project. Sorry, see, I'm doing that already. Yeah, we're already doing this. An example of can be used to pass on QEMU directly, flash file, IDF.py. Since it's just creating a GDB server. There's got to be a way. So the QEMU GDB creates while debugging. Yeah, because what I want to do is I want to be able to like use the thing here. I'm just do run and debug. Yeah, so it's going to try and use the. There's going to be some magical incantation that we can put in launch.json that will allow us to do this. I am convinced of that. We would just add a configuration here. Start up QEMU with GDB that this can attach to. I'm not sure how to do that, and I'm about at time on the stream. So I think I'm going to call it a day. We got the dev environment fully set up. Yeah, and QEMU's working, so that's really cool. To have the last step in that would be to have step debugging working, so that you can actually use the built-in VS Code debugger and stepping and step into and stuff. That would be super cool. If I get that working, I'll do a stream on it, but. Nightcry, like you, work's killing you. I actually have to get back to work as well. So that's going to do it for today. I appreciate everybody watching. Thanks so much. If there's anything that you want to see, drop it in the comments. Anywhere this video is posting, it should be posting to LinkedIn, Twitch, and YouTube. Drop comments in there. I'm happy to take requests for stuff that you'd like to see on the ESP32. Otherwise, I'm just making this stuff up of what I find interesting and want to learn more about. And so now that we have the environment to do that, we can kind of just let it rip and try a whole bunch of different things with different chips, and should be a good time. So thanks so much for watching.